Hey, today I will discuss about the GANs Generative Advanced Networks model for composite material image generation. So I'm Baran Kumar Boddo. Uh, Overall overview of the composite microstructure of GNN. So first of all, we will have two models. One is generator, another is uh, discriminator. Okay, so actually the generator that will take some random noise or fiber orientation optimal condition like this. So they will make some fake data, add synthetic composite image or face composite image. Um, Also, they will pass it is real or not. The discriminator, and they will prove that the generating image real or fake. So they will um, compare many times and make the real type of image. Okay, so that's right. So now I will uh, describe deeply. So introduction, if I say that com composite materials, actually, it is largely used in engineering sectors, even and also image-based analysis. This image-based analysis will help you to microstructure-related evaluations, the predictions, and various type of. Uh, this means microstructure situated religion. AI generated systematic image for recent training. So what are the GANs? GANs means I have told it before that generative adversarial are networks. It introduced by OK. Also, it has the two networks. One is generators and discriminator. We have seen it in pictures. So realistic image generations, not only the composite material, any kind of realistic image generations. Making purposes GANs are used. Uh, so generator create the fake images, discriminator distinguishes the created image which are real or fake. Also, they will training is a minimax games. I will discuss it later. What is minimax games? And improves the iterativity. So the image quality means image quality. So why GANs are for composite materials? You know that there are a lot of machine learning models, generative models, among them why GANs are used in here. So generate microstructure image, reduce experimental cost. You know that the APA analysis or real time analysis or need huge time and cost within second. We can easily get the result. That's why we can easily reduce the experimental cost. Augment dataset for machine learning models. You know, this for machine learning, where you need a lot of data set, but we do not have sufficient. If we do not have any sufficient data sets, so we using the augment program or coding, so we can really make the million of data set. So that means we can augment it. If I say about the composite materials, ply and sorry, resin and resin and matrix angles, composition, etc. We can make changing on volumes, augmented, improve the simulation accuracy, obviously, because many data sets are needed for us making the simulation a good accuracy. Input of data. Input data for GANs. inputs data for GANs. So with fiber orientation, volumetrics. This means matrix material properties, curing temperature, and microstructure images. We can use both microstructure image and that means various type of fiber orientation, 90 degrees, 0 degree, 45, 60, and 30 degrees. Volume fractions, the resonant matrix volume fractions, it can be 0.6 or 0.4, 0.45. It's a matrix materials properties. You know that various materials properties like tensile strength, shear strength, ultimate strength, securing temperature. So when the uh, that means composite material will make there need some temperature. So which temperature it has meant it can be used as an input in ER and a microstructure image. We can get a SEM or CT scan, etc. Application. So why GANs are used? Crack detection simulations. You know, there will have there may have various detection. That means cracking during the um, uh, like composite materials of make productions. So after seeing this image, we can easily detect the crack fiber distribution modeling. So how how the fiber has a distribution, distributing each other. Porosity predictions is like a crackdown and surrogate modeling instances. This is very important use because uh, if I want to simulate any composite material in ANSYS, I'll need a lot of time. So also many that means many models need many times. So we can easily simulate it using GANs and the output result using ANSYS for simulating the um, workflow. So first of all, the workflow, if I say that you have to collect data set, SIM images or CT scans images or synthetic images, pre-process image. So you have to need some pre-processing. If I say that that means feature engineering. Actually, we can say that the feature engineering, we will see it later in discussion. Train the GANs models. Obviously, what you have made was the train the GAN generate synthetic image. After training the GANs models, the synthetic models, that means image, valid the with exact when you create the synthetic image or artificial image, must have to prove that this is real using the experiment. Tools and technologies, this is very important. For instance, Python for programming, TensorFlow or PyTorch for this is library function, and since for simulation, obviously, it need ANSYS or Abacus, whatever that means APM software, and offensive for image preprocessing. So this is also library. Advances. What are the advantages of this? A reduced cost of experiments, improved dataset size, and that means in the database size it is increased, generates high quality image. If you have any low quality image by using the facial extraction, this means models or program, we can that we image quality can be had that we will support AI driven challenge. So everything has positive sides and challenging sides. So training instrumental sometimes need a lot of time and it will not give the proper that means proper what I will say that training will not be stable. So you will get some noisy data, etc. Mood collapse, that means require large data sets. So uh, for machine learning purposes, need a large data set. If you do not have, it is very hard to get the real type of data sets. Computational cost, sometimes it may be computational cost may be high because you need a special hardware or processor or even some um, future scope. Yes, future uses scopes integration with digital twin when you will make it automatically real-time defect predictions when the composite material will make the defect can be identified instantly. Hybrid physics and AI model hybrid physics such as that means as it is simulations that has the industry for application conclusion. So if we apply in that the say what we have learned about the GANs. GANs are powerful image generation. So it's true. Using this you can make a lot of image useful composite material research because mm, uh, in traditional method it is very uh, hard to maintain the number of image generations or property analysis. So help simulation and optimizations. Obviously, future research is also. So thank you very much.